Right, so we are on lesson 48. Yeah. Right, lesson 48 now, we're solving triangles. So the first one is this example that we're going to be doing together. That we have a triangle, and now in grade 12 it gets to be three-dimensional. So it can be that you've got something on a horizontal plane. So say for instance we've got a playing field and we've got vertical flag posts or buildings or whatever. So you can see we're working in more than one dimension. Two-dimensional is a flat surface. When you've drawn your triangles and circles and whatever on a flat surface, circle, and then if it's three-dimensional, it means that you are working flat as well as standing up. So just read the question. This one had nothing to it because they didn't say anything about a playing field and a soccer field and a lamp post and a building and a whatever. Because then usually you've got to know that the building will building will be perpendicular to the ground, for instance, which they don't indicate on the sketch, but you know it's got to be 90 because hopefully the guy that built it knows what he's doing. Then a building should be perpendicular to the ground. Are you with me? So stuff like that is going to come. But in this particular question, they gave me, and we've already put some stuff in there, we've got the 2x given and the x given. So the obvious thing to do is to find this straight line, knowing that that would be 180 minus 3x. Happy on that? They gave me that these were parallel lines. So that meant if this is x, then that should also be x because of alternate angles. This x was given. So the first thing that ever you do when I give you a sum like this is find all the angles. That's why we first tried that one. Secondly, we are finding this one not secondly, whatever you do first. Because I think easier would have been in this big triangle ABC. You've got 90 and you've got 2x. So that has to be 90 minus 2x. Right, remember it is 180 minus, but you've been taught in trigonometry already. The moment that this is 90, I don't think 180 minus. I think those two together should be 90. So if the one is 2x, the other one's 90 minus 2x, making your thinking and your procedure a little bit streamlined. So that's why this would be 90 minus 2x. Then to find that angle, if for instance I had a big triangle here, then I could find the angles as well by using some of the angles of a triangle somewhere else. But that one I can only find by finding the sum of the angles of this big triangle ACD. Now how would that work? Okay, also there I wrote 180 minus x. I don't think we're going to use it, but it would be 180 minus x because of the straight line. And the same thing here, 180 minus x. It could be that we're going to use them, but we find all the angles inside of triangles because we are solving triangles. So we would like all the angles we possibly can get. If we can get them all, fantastic. If we can't, then we're going to work towards it. So how did we find this x that I wrote in there? So you first all going to add those two together, which is 180 minus 3x plus x plus x. How much is that? 180 minus x. Are you with me? 180 minus 3x plus x is 180 minus x. So if these two are 180 minus x, then this should be to add up to 180. And if it's difficult for you to just do it up there, write it down. 180 minus, and in brackets, 180 minus 3x plus x, close the brackets and do the little sum and you'll find that it is x. You're not getting extra marks for being quick. You're getting a mark that it's x. Whether you took 30 seconds longer, it doesn't matter. Rather be safe than sorry. So now I've got all the angles. Now I can actually look at the question. They asked me to find angle CAD, and I've solved it because of the natural things that we always do. So CAD would be equal to x. Do I have to tell them how I got there? You don't have to. Because this is not geometry. This is trig. If you were in trig, you had to tell me how you got to the alternate angles, how you got to the straight line, and how you did some of the angles of a triangle. But if you just wrote the X there, it's fine. With no reason, it's fine. So most probably you would have had 2 marks for this. And guys, this is why it's so important that you show on your sketch everything that you've done. Because there might be somewhere you fell off the wagon, but then I can follow what you did on your sketch with the stuff that you wrongly worked out and then worked with it further correctly. Okay. Number B is saying that you've got to prove that CD is equal to. Now CD is a length of a side. Important, when you're working with solving triangles, you're trying to solve angles and sides. So find all the angles that you can, and those that you can't, you're going to work out with sin rule and cos rule. And the sides as well with sin rule and cos rule. But the CD is inside which triangle? ACD. Do you agree? Yes. Please remember, constructions are almost exclusively for theorem proofs in geometry. You don't really construct anywhere else. If you're getting the notion of constructing a few things and making lines longer and whatever, don't. Usually that's the wrong thing to do. Unless the sun says, hint, draw this line in, then you do it. But in general, you're not going to make longer lines and make your own triangles and start different things doing them. Okay, that's a rule. So if I want CD in this triangle, I need at least one side. All of them, the sin rule with the cos rule. You need at least one side. So I can do nothing in this triangle. The only side I do have is K. Right. So inside of triangle ABC, and you don't have to write that. Ma'am likes you to write it so you can tell the marker where you've gone. So inside of that triangle, you're going to work out what? The connecting side, the common side, which will be a C. And what tool are you going to use? The sin rule, the cos rule? Okay, can you use grade 10 trigonometry? Meaning what? Pythagoras? Grade 10 trigonometry would mean if I want this side and I have this angle and I have this side, I can say, according to that, this is my adjacent side and this is my hypotenuse side. Way back when you were in grade 10. This was your hypotenuse side and this is your adjacent side. So you could say adjacent over hypotenuse is cos of that 2x would give you what? The k over AC. Are you with me here? So that k would be, sorry, not k, AC would then be equal to
k over cos.
So when we want to get AC alone, we would use my method that I call cross multiplication or swap them around. So AC is equal to k over. Okay, I'm very happy with you. That was grade 10 method. If you wanted to use the grade 11 sin rule, which sin rule is always better than cos rule because it's much easier. If you wanted to use the sin rule to find AC, then the sin rule always has to be done first. You've got to write it down. Whether the triangle is ABC or XYZ, it doesn't matter. Call this, write down your sin rule. This side that I'm looking for is AC, and I'm going to put AC then over the angle, which is sin. And what is sin 90? Because you know your special angles. And then B is the other side that you've got. What other side have you got? K. And K's partner is? Which is a totally different procedure, but it gets to the same answer. Because now remember that's 1, so it just falls away over 1. But then this will become cos 2x. So this guy had to go and use your co-functions, depending on your technique that you try. But you get to the same answer. Everybody happy on that? Yes. Perfect marks, perfect marks. This looks a little bit quicker. Doesn't matter. Once you know what you're doing, both of them is fine. So I've got this one. Now usually when we've got inside, we write it on here. It's really not very much space, but if you can, you do write it. Otherwise, Nam has taught you, just make a little tick there and say, okay, I have it. Now I can go to triangle
ACD.
And I'm telling them, listen, I'm in triangle ACD. So in that triangle ACD, we are going to find for,
CD.
please focus on what you're aiming for CD. So now I'm going to also again try and use the sin rule. Do I need to write the sin rule down again? Okay, because I've done it before. I've written down the rule, I've done the substitution, get the answer. I'm in ACD, so I don't have to write down the sin rule in terms of A and C and D anyway, but you can if you want to. But it's going to be the side CD over the opposite angle of
X.
so it's going to be sin.
X.
And then the other partners that I've got is this side. I'm first going to write AC for a moment, just to, okay, if it's okay with you. AC, which is that one over.
Sin 2x.
So AC is over. Happy on that, guys? This angle is 2x. So, guys, I did this for nothing. No, you didn't. You used that to get to the x, but we never wrote it down. So very often they do give you marks on the sketch for having all the stuff that you needed on the sketch. Make sure you work very neatly and cleanly. Okay, then I need to swap this all around and hopefully here's my memo, my crib note I need to get here. So I'm going to have the AC being equal to K over cos 2x. And that's over
Another one.
sin x, sin 2x. Can I just do this?
Yes.
Understand what ma'am did?
Yes, ma'am.
So it's AC, which is a fraction, divided by sin 2x.
We need to get inside.
This is divided by sin 2x because it's timed with 1 over sin 2x. It's the ways, various things that I've shown you that help you when you've got those techniques. And the other side is still,
CD over CD.
can I bring that sin across already? Why not?
Don't try to support.
If you do, where's it going to go? At the top. So can I do this? Eventually we're going to put them all together, but I can separate them and put them together as I like and as I play along with it. So this sin x is going to be timed over there. Please don't divide sin x and sin 2x. Okay, because of the angles. And then how did they possibly get to their answer? Because I'm happy with 2k sin. I've just got k sin. How did they get here? Why is this done in grade 12 and not last year?
Because of the double.
Because of the double angle that you're going to have to use now. Do you see it?
Yes, ma'am.
And you would have left it like that, most probably, if I just said find it. K sin x at the top, sin 2x, cos 2x at the bottom. Maybe you'd have an inclination after lots of practice, but that could be a sin double angle. Do you see the sin double angle?
Yes, ma'am.
Because it's not really there yet. Sin 2x, cos 2x is there, right? And the top is k, sin x. How did they get to sin 4x? I'm shorting something there. I'm shorting it too. Ma'am, wait. You can't just put a 2 in there. You got to do it legal. Both sides? Legal. So to make it legal, just put it on at the top as well. So then the bottom one would become what? Sin 4x. Because it's 2 sin 2x cos 2x, making it sin 4x. It's always a little bit more mind-boggling when it's not just sin x in cos x. Okay? And the top then is what I wanted it to be, namely 2k sin. It's almost like left-hand side, right-hand side, these sums, because I'm trying to prove something that they've given me. Right, questions? So please just on page 173, change this in your textbook. There's a mistake. They're trying to prove BC, just like you're trying to prove this answer. They give you the answer, but you never get to the one that they've got there because they're missing an x there in front of the square root.